Hello students, my name is Priyanshu Malik from B.S.C Chemistry Honors final year. Today we will talk about carbohydrates. This unit is in our 5th semester syllabus. Let's start. Carbohydrates are the hydrates of carbon which on hydrolysis or gives polyhydroxy or ketones. They are generally polyhydroxy or ketones and also on hydrolysis give polyhydroxy and ketones. Carbohydrates can be classified into three types mainly monosaccharide, disaccharide and polysaccharide. Monosaccharide have 2 to 8 units of carbon and cannot be hydrolyzed further into any subunits, while disaccharides can be classified or hydrolyzed into 2 to 9 subunits of monosaccharides, and polysaccharides can be hydrolyzed into many subunits of monosaccharides. We can also classify carbohydrates on the basis of reducing or non-reducing sugars. Reducing sugars which reduce into other components of like hydroxyl groups and other groups. Polysaccharides are only compounds which are non-reducing sugar, while the monosaccharide and disaccharides are reducing sugars. But exception of this is sucrose, which is a disaccharide which cannot be hydrolyzed further because of the presence of both keto and aldose group in it. The aldose group is of glucose and the keto group of fructose. Now we talk about glucose. Glucose is the monosaccharide which structure formula is C6H12O6 called as the grape sugar, which the glucose have a aldose present in him, and on reaction with HCN it gives cyanohydrin, and reaction with the hydroxyl it gives oxide, and on reaction with phenyl hydrazine it gives phenyl hydrazone. To verify this will verify that the glucose has carbonyl group present in it. To verify that the glucose has an aldehyde group, we can react the glucose with bromine, water, and H2O on an acetic hydrolase, which give a carboxylic acid. Carboxylic acid, which then determine that an aldose group is present in it. To determine that the glucose has 5 hydroxyl groups, we can react the glucose with the acetic anhydride. After reacting with glucose with the acetic anhydride, it will give glucopenta 5 glucopentaacetate, which determines that the 5 hydroxyl group is present in it. The 5 hydroxyl groups are not attached to a single carbon but attached to different carbons. This can be proved by that glucose is not lose its water easily. So this proves that the glucose have 5 hydroxyl groups on different carbons. To determine that the glucose has a straight chain structure, we can determine it by reacting with the hydroiodic acid and phosphorus, which gives N-hexane, glucose N-hexane, and hydroiodic N-hexane, which determines that the glucose has a straight chain structure. To determine the alcohol group which is present in glucose to be primary, secondary, or tertiary, its nature can be determined when we react the glucose with the HNO3, which is nitric acid, which give 2 carboxylic acid. The 2 carboxylic acid can be present only by when there is a primary alcohol group is present. This determines that the primary alcohol group is present in the glucose. and it is attached at the last carbon of the glucose. This proves the, that the glucose has a carbonyl group, a aldehyde group, and has a straight chain structure having a primary alcoholic group. Or primary alcoholic group have a, and have a straight chain structure alcoholic group, a